Chemistry time. Natalie. Chemistry time. Look cheerful. Take your hat off. Good job. Okay, we're going to talk about something called net ionic equations. Net ionic equations. I love this. Like I said, it's at first it seems difficult and it seems complicated, but once you get, like, it's a organizational thing. Once you get it well organized in your brain and you get to the point where you've done a few of them, it just takes practice and you're going to be really good at them. So the reason that we do these is regarding double displacement or double replacement. We call it either one. I switch back and forth. Double replacement reactions. And you remember, what is the general form for a double replacement reaction?
It's like A, B, or A, it's like AC
Look,
then?
AX, look back in your notes.
Plus C.
BY
Okay, never
yields.
AY plus BX.
Yeah, they switch their partners round and round, right? It's like a do-si-do. AX plus BY yields AY plus BX. And do you remember, look back in your notes before you just answer either not at all or incorrectly. Do you remember how we know when this kind of reaction has occurred, right? Because it doesn't always happen. We know what happens. We can always tell what would happen if it does occur, but how do we tell when a double replacement reaction has occurred?
I did this again.
Say it, Nesmith.
It's something with like solids.
Yes.
And gas.
Yes. So if one of those things, if one of the products, which are these two, right? If one of these products is if one or more product is a solid, liquid, or gas, the reaction did occur. So to the uneducated chemist, it might seem like these are the only options, right? But usually the rest of these things are in what, we don't really call it a state of matter, but in what status are these things? They're not solid liquids or gases, they're in what status? What's the other one they can be? Look with me on page, real quick here, let's look at an example on page 299. The very first example there on 299. What state are all these things in? It just, all this is telling us how hydrochloric acid dissociates. It says HCl, hydrochloric acid, yields hydrogen ions and chloride ions. What state are these things all in?
Aqueous.
Aqueous solution, right? So usually these things will almost always both be in aqueous solution. So these things are usually both in aqueous solution, and in today's example they always will be. And then the reaction did occur if one or both of these are not in aqueous solution, okay? And we use to determine whether that is going to be the case or if it's not going to be the case, we're going to use a little chart. Either it'll be given to you or we're going to use a little chart that I'm going to give you today that I'll print off. So let's do an example of these. Let's just look at a basic one here real quick. So this one says, I'm on page 300 now, it says NaOH. Oh golly, that's the ugliest NaOH I ever drew. Let's try one more time. NaOH in aqueous solution. Name this thing.
Oh, sodium hydroxide.
Sodium hydroxide plus CuCl2 in aqueous solution. Name that thing.
That'd be copper oxide.
Copper. This is not oxygen.
Dichloride.
Copper 2 chloride. Remember?
Oh, I think that was a zero from here.
No, this is Cl. Copper 2 chloride. Remember, because it's ionic, but we also have to name the oxidation state of the copper. This is copper 2 chloride. Yields, it says, well, we don't even have to look in the book, do we? They switch their partners. So it's going to be NaCl plus CuOH2. This is an aqueous solution according to the book, and this is a solid.
It works because one of them is a solid.
Right. And so the first question is, did this occur? The answer is yes, because look, this is a solid. And by the way, what do we call a solid that comes out of solution like this? There's a special word for it.
Oh, I don't have
Can you give us a hint?
solid.
You have it in your notes. That's a good hint.
Is it
A solid that comes out in solution.
S?
It's a vocab word. There's another.
Does it start with an S?
Nope.
Does it start with a P?
It does start with a P.
Properties.
No.
Products.
No, those do both start with P's. You're right in that regard.
Precipitate.
Precipitate. Precipitate. Write that down. Write that down. This is called a precipitate.
No, you didn't. You said property.
Precipitate.
No, I said it before.
So this one, a long time before, a precipitate. This one, so a solid, listen, a solid that comes out of a double replacement reaction like this is called a precipitate. Get rid of that little guy. So now we're going to do the meat of this lesson, which is that we're going to show the net ionic equation for this thing. So to do a net ionic equation, the first thing we need to do is find the complete ionic equation. So for these things, we're going to have a complete ionic equation. And then we're going to, the actual answer we're looking for is called the net ionic equation. Okay? I wanted these to line up, but they didn't, but that's okay. So the complete ionic equation, first thing we need to do, write this down somewhere, the first thing you need to do is balance your equation. The first thing you have to do is balance the equation. So let's balance this. Is it balanced?
Yeah. No.
I'm going to erase this little box right now because that'll throw off our balancing, or maybe it'll throw off our balancing.
So there needs to be a 2 in front of the NaOH.
To even that out.
Okay,
But then there has to be a 2
There.
So now it's balanced.
now it's balanced.
Wait, but then we have 4 chlorides. Wait, what?
No, we don't.
You never-
2 sodium, 2 hydroxide, 2
Oh,
hydroxide,
okay.
1 copper, 2 chlorine, 2 chlorine. So the complete ionic equation, what we do is this. You have to, you should write, so I'm not going to write down the steps for you, but you should probably write them down. You have to break apart, well, I'll just write it down, I guess, I don't care. Step 1, break each ionic aqueous substance into ions using coefficients for amount. So first of all, let's talk about this sentence. We're going to take each ionic aqueous substance. How do we know if it's ionic?
If it's not covalent.
Good.
If it-
How do we know though? By
A
looking
metal
at
and a non-metal.
a metal and a nonmetal. So if it's a metal and a nonmetal, or if it has a polyatomic ion, it's ionic. How do we know if it's aqueous?
It says it.
It says it. So we're going to break each ionic aqueous substance into its ions, and we're going to use the coefficients for the amounts. So how many sodium do we have here? 2, and we write each one, 2 Na. But we have to break it into ions. What's the charge on the sodium in this problem? What would the charge be?
4.
You just, I think, guessed a random number. What's
1.
1? Sodium is always 1 what though? Plus or minus?
Plus.
Plus. So we write this. So write this with me. 2 Na plus 1. Do you see where the 2 came from?
Yes.
It was the coefficient. Do you see where the Na came from? Well, that's what we're working with.
Yeah.
And then its charge we got from the equation or from the periodic table, doesn't matter. 2 Na, and we have to derive state, aqueous solution, plus, how many hydroxides do we have? 2. Did you say 2, Aisha? Yes. 2 OH, what's the charge on the hydroxide? Negative. It's OH minus. And is this an aqueous solution? Yeah, because it's still part of. Do you see what we're doing? We're breaking apart. We broke this thing up into what it's made out of. 2 sodiums and 2 hydroxides. Right? So far, so good. Do you have questions so far? You're good so far?
Hold on, let me look at it.
Okay.
Sure.
Do you have a question, though?
I don't think so.
So far, so good, right?
Yeah.
They're both aqueous, so we have that. They both have, there's 2 of each, so we put that. And then their charges we got from the periodic table, or from the symbol.
So do we have
Plus, how many copper do we have?
1.
Just 1. So we're going to write copper. What's the charge on the copper? Don't look at this for that one, because you have to look at this.
Oh, plus.
Plus 2. How do you know?
Because it's a transition metal, so it's
Not always. That's not always how we do it.
chlorine.
Because it's bonded with 2 chlorines. And the chlorines are always -1. And so if it's bonded with 2 chlorines, its charge must be 2 plus. And that's an aqueous solution. Plus, how many chlorines are there? 2. Now here, make sure you do this because we're using coefficients for amount. So 2 chlorine. See, I made that subscript into a coefficient.
Okay, say that again.
So it's, because there are 2 chlorines here, I make that into a coefficient because I use the coefficients for the amount. The polyatomic ions, like if it was SO4, for instance, like sulfate, that subscript stays because that's part of SO4. Like, you know, the thing's name is sulfate and it's SO4, right? But since this subscript is telling us how many chlorides there are, we put that as a coefficient instead. Okay, and what's the charge on the chlorine always?
1, but it'd be 2.
1 minus. 1 minus. And in what state is this in?
Wait, did you put 1 minus up there?
Yeah. What state is this in? Aqueous. Yep. Aqueous. I'm going to run out of room. You don't go to the next line, but I'm going to have to
I
because...
have to go to the next line.
Me too.
So, luckily though, we have yield. So I'm just going to make my yield arrow look like this. That's not how it's supposed to go. Yields. Now we break this one up. How many sodiums do I have on this side? 2.
2.
In A.
Same thing.
Hold up. We're going to find out in a second. This is the whole point of doing this. What's its charge?
Plus 1.
Plus 1. And its state?
Aqueous.
Aqueous. Plus how many chlorines?
2.
2 chlorines. Its charge is 1 minus still, and it's an aqueous. Oh, look here as a little side note. Look, on this I put OH just regular minus. On this I put -1. Does that make a difference? No, if you just put minus, that means -1. If you just put plus, that means +1. Anyway, now here's where it's important, is that anything, look at our criteria again, break each ionic aqueous substance into ions. Is this an ionic substance? Yeah, it is. It's a metal and a polyatomic ion. Is it ionic? Yeah. Is it aqueous? No. So can we break it up? No. So we write CuOH2S as a whole substance.
Wait,
This is
how'd you know it wasn't aqueous?
because it has this little S
Oh,
right
I
next to
see.
it. And that was given to you in your book. So your problem will say that that one was solid. This is the complete ionic equation. It's called that because it's the whole thing, and we broke them into ions, right? Complete ionic equation. Now, what we do to get the net ionic equation, what's net mean? If I'm talking about my net pay, or if I'm talking about the net force on something, what's that mean? Net worth, yeah. All those things net in that case means what? Yeah, total. Total added up minus the things that are gone, right? So like my net pay is how much I make after the taxes are taken away, right? Someone's net worth is how much money they have minus how much debt they owe, right? So for this net ionic equation, it's going to be, can you guess? What are we going to get rid of in this? Kind of like algebra.
On the other side.
The things that are the same on both sides. Did someone say that? Pretty close. So look, the sodium is the same on both sides. In both cases, it's 2 Na plus 1 aqueous. Is there anything else that's like that?
The chloride?
The chloride, yep. Anything else?
No.
Nope. So then all we do for the net ionic is just bring down the stuff that changed. So we have Cu plus 2 in aqueous solution plus 2OH minus. I just did it in a different order because that's the way it's going to show up in the answer or in the products. Yields CuOH2 solid.
Okay, 2 liters.
So the first thing we had to do was we took our equation, we balanced it. That really should
No,
be
that
done.
is this.
Step balance. Yeah. We took our equation, we balanced it. Step 1 was we broke all the ionic aqueous substances into ions. And then step 3 we just cross out. You had a vocab word for this. What do we call the ions that are the same on both sides of the equation? It was a vocab word. Did you guys do your vocab?
Oh,
I remember that I checked it. Oh.
Can you ask the question again?
Okay, I'm going to ask the question again. What do we call the ions that are the same on both sides of the equation? Say it. Say it louder and prouder. Spectator. Cross out spectator ions. What's a spectator? Dude who just watches, right? Spectator in a football game is the person watching the football game. These ions are just hanging out and watching. They're not doing what? They're not participating, right? Does the spectator participate in the football game? No! The ref will shoot him in the head if he tries to do that. If someone tries to come onto the field when they're supposed to be spectating, bad. Don't participate if you're a spectator. These spectator ions are not participating, right? So we cross out the ions that don't participate. Questions about that?
Nope.
And then we just, it's 3, I guess you could just write the net ionic equation. Bring down everything that wasn't a spectator ion. If you follow these steps, and if you think about this in an organized fashion, you are not going to have a problem with this at all. You're going to think you have a problem with it at the beginning, some of you, because you like to whine. But then you're going to realize, I just need more practice. And then you're going to practice and you're going to be good at it. And then by the time you take the test, you're going to get A++. Do you have questions about any of this, though? This is just one example. We'll do more. But for the video, do you have any questions?
It's a big example.
Well, this is like the smallest one there is. So they get bigger than this. Bye! Okay.